Everyone, in the last video we studied about why we have to give a default state in a digital pin, right? For a digital pin to get a digital input. And also we studied that we came to know that there are two ways to do that, to give a default digital state to a particular pin and to give a digital input after that. Okay, so those two ways are actually called pull ups and pull down methods. So you can see here with the two arrows, pull down and pull up methods, right? So today we will study about one of the methods and how it is actually implemented in circuit as well. So if you understand the circuit, then it is very easy to you to understand the coding as well. So there are two things, as I said, you can see on the top, like the picture is going on, right, okay, here, pull up and pull down, right? So today out of the both we are going to study about pull down. Okay, so what actually pull down circuit is, pull down methodology is, we are giving, anyway, by both ways we are going to give a particular state to that particular input pin, either it is high or low, even before the input comes, even before we think about the input source like switch or whatever, sensor or something. So we are going to make that particular pin in a state either high or low. So when it comes to pull down, what we do is we initially make the particular state of the pin as low, that means ground. Okay, so when it starts, the pin is going to be a ground pin, ground connected pin, or zero pin or low pin. So with that input we can either give or low, give high or low, that is up to us, and we can see the difference. So if you don't understand, don't worry, when I explain you will understand. So look at the picture in the step 1. Okay, the step 1 picture. So if you look at, like, don't look at the second one, look at the first picture, right? So in the first picture you can see, okay, fine, this fine. Look at only the first picture, not the second one or third one. The first picture you can see there's Arduino and pin number 2. So I mentioned as D because this is digital pin. So there's a wire coming from pin number 2, or you can say where a wire is going to pin number 2. That means the input is, the input wire is going. Still we didn't connect that input, but still there is a wire that is going to go to the pin number 2, that is going to the pin number 2, and the wire I'm sorry, on the other hand, having a resistor. So that particular resistor is a 1 kilo ohm or 10 kilo ohm or any resistor you can use. There is no actually a specific voltage resistance actually. So 1 kilo ohm would be fine, or 10 kilo ohm, or whatever kilo ohm you can use. I don't know whether you can use 330 ohm. So I tell you to use 10 kilo ohm, that's fine, or 20 kilo ohm, it's fine. So other side of the resistor is going to ground. Okay, ground pin. So now you can see there are 3 points I have mentioned, to easy to study, A, B and C. So A is the ground point, B is the next side of this resistor, and C is the point that is going inside the pin. So those are darkened, right? So if you don't understand which A, B, C is, you can have a look, refer that second picture. There are arrows with A, B, C. So the same locations are in the A, B, C. So now come back to the first picture again. So this is easy, right? So now the problem is, you may ask me, okay, if you want to give a particular pin, a particular state to a particular pin number 2, why don't you directly connect that pin to a ground instead of having a resistor? Yeah, so I will tell you later, because this is because when there is a high input is coming, the system may short circuit them, because the high input is also coming pin number 2. If there is no resistor, +5 and ground will be meeting, because ground is already there in pin number 2. So that is why we have a resistor. So you will understand when I explain it. So just don't worry about that now. So now you tell me, what are the resistance voltage values at A, B and C? So obviously the voltage value in A is ground, or we can say voltage of A is 0. That is obvious. So what about the voltage of B? Will there be a voltage high or low than that? So you can think how the voltage is defined is V is equal to I into R. Okay, V is equal to I into R. So the voltage drops and everything you can define by applying that particular equation, V is equal to I into R. So V means voltage, I mean current, R mean resistance. This is obvious. So V is equal to I into R, right? Okay, so there is a resistance here, let's say 1 kilo ohm. So R is there. So what is the I value? Is there a current going through the system? If there is some current has to go to the system, go through a circuit, the thing is, from wherever the current is going, it should come to the same place. That means if you have a battery with plus and minus terminals, if the current is going with plus terminals, from plus terminal, it should come to the minus terminal of the same battery. Then only the current can go. it has come back. So there is no such thing. So ground is there, resistor is there, Arduino pin is there. So Arduino pin is not the power source anyway, and ground is also there. So from where to where it is supposed to go? There's no current actually running in the circuit. Okay, so there is no complete circuit here. So how do you can feel about this is, and there is also, you don't see any voltage drops like that. So there is no current actually, because there is no way to come back for the current to. Okay, if the current is, let's say, going from pin number 2, it has to come again to the Arduino, maybe the ground of the Arduino. If the current is coming from, let's say, just say from the ground towards Arduino, then it has to come back to the ground. There is no way to do any of these scenarios. So there is no current running, right? So V is equal to I into R. You know that equation, right? So otherwise you can Google the equation for the relationship between voltage and current, or between voltage, current and resistance. Then you will see that equation. If you don't know, go have a look on the V is equal to IR equation and come back. So as I said, there is no current running. So I means 0. So V is equal to I into R. R is there, but I is 0. So what is the voltage value? It is 0. So we can say this R is the resistor value, right? Okay. So whatever the voltage value, voltage fall or voltage fall, we can say fall, right? Or voltage drop within the resistor is 0. That means there is no voltage drop within the resistor. So that means what? The day the resistor stays within A and B, right? Since there is no voltage drop within the resistor, the ground voltage in A will be in the same, the same value will be in B as well, because the resistor doesn't hold any voltage drops. So whatever the voltage in A will be in B, because we don't know the B's voltage value, but we have ground at A. So since there is no voltage drop, these are all look like same wire, A, B, C. Okay. So A value is ground, so B is also now ground, because there is no current is running. Same value. And C is also now ground. So if there is a current running throughout the system, by we connect something like that, if we are connecting something, if there is some current is running through the system, then there may be a voltage drop within the resistor. Okay, we will talk about that later. So now we know this pin number 2 is ground. A is ground, B is ground, and C is ground. So now the pull down circuit has completed our first task. What is that? We successfully give a particular voltage or state to pin number 2 at the initial state. Okay, at the initial state. That is understandable. Let's move to the pin number step 2, right? Now we are going to do something else with the same circuit. So we are going to add something else to the circuit. So once you did this, move to the next point. So why I am doing it in 3 pictures is, sometimes people may find to make real connections looking at this diagram. So if I do it by step, then you can connect. This is easy, right? For pin number 1 is, step 1 is easy. So now you have to add one more thing into step 2. So if I draw the whole diagram, then it may confuse you. So now what you will do is, you will find a push button. So now you know how to connect a push button, right? In a way that has to be connected. Okay. So let's think about a push button with 2 terminals, or you know how to connect the 4 terminals push button as well, like a two terminal push button. So let's say there's a push button, there are no connection between the 2 terminals. So there are 2 small rounds you can see here. So those are the terminals of the push button. If you push that push button, the terminal, both of the terminals will be connected by the push button. Okay, button will create the circuit completed. Okay? If you release it, the circuit will be incomplete again, right? The completion will not be there. So you know what I mean, right? So so one end I am saying as one terminal D, other terminal is also connected to point number B. Okay, point B. So now you know how to connect, since I mentioned it as point wise ABC. So you know ABC points. So you bring the push button and connect one side to point B, and other point is existing there like as point D, and ABC we already know. So there is no problem. So to the circuit in the step 1. Okay, when we move to step 2, we are connecting only one push buttons, one terminal. Okay, we don't do anything else. So even if I press the push button, nothing is going to happen, because D is not connected to anything. Okay, so now this point B is obviously A, B, C and everything is in ground state, and pin number 2 is also in ground state. So that is understandable. So now we will go to the step 3. Okay, so what we will do is, so now we have up to this in the, look at the third picture. So you can see now it looks like same as the picture in the step 2, second picture. And what we do is, the D point of the push button we are bringing to +5. Okay, we are connecting to +5, and I mentioned this point as E, so that I can easily explain you. So now look at the full picture of the third picture, right? Full third picture. So now you can see everything is completed. What we did is we had the resistor ABC path we already have, we know this, and in the second line we connected one terminal of the push button to the point B. So if you remember it as point A, point B, point C, and you can simply connect this circuit in real life. Okay, looking at the diagram, you can create the circuit. I'm sorry. So we connected the switch. So what actually we have done in the third picture is we take that the D point of the terminal, D terminal of the push button, that means other terminal of the push button, and we connect the push button, that terminal to +5 voltage. So what you can do is you take a wire from that terminal, D terminal, and you can give that connect the wire from D terminal inside the Arduino's +5 pin. And also pin A point should be going to Arduino's ground. So both are all same. Okay. So just don't worry much, but just focus on this, right? So now what will happen? Now let's say I didn't push that push button, right? I didn't push it. Okay, it's open. So the circuit is open. Now you can tell me what are the voltage values. So at A, it is ground. There's no doubt on that because there's no current running. Even though if you connect it to Arduino's ground pin, we don't know the exact voltage value on pin number 2. So it is undefined. So there's no current is going to run. Okay, just remember that. So we can dig into this why there's no current running. Just don't worry about that. No current is running. So there is no voltage drop across the resistor. So A is ground. Since there is no voltage drop, B is also ground. Okay, 0 voltage, and C is also ground. So as we planned initially, the Arduino pin state is ground state or low state. Then we have a push button that is also there in the B point. So now you can see B is like a T junction. 3 things are connected in the point B. Arduino's pin, one side of the resistor where the resistor's other side is going to ground, and also one side of the push button. Okay. So now push button is open. Then what we do is we bring a wire from that push button's other terminal and we connected it to Arduino's +5. So forget about that. So what are the voltage values? A is ground, B is ground, and C is ground. There's no doubt on that. Okay, 0. So what is the voltage value of D? 5 voltage, because we connected it to 5 voltage, and E is also 5 voltage. So now you can see there are 2 sides to the push button, 2 terminals that are not connected now. One terminal is 0 and another terminal is +5. So now what I'm going to do is I'm going to press the push button. Okay, I'm going to push it. Okay, so if I press the push button, okay, if I press the push button in the third picture, what will happen is there is going to be a connection created between terminal B and D. So B and D are going to be connected. So D is 5 voltage, B is ground. So now what is going to happen? Both are going to be connected. So what is the new value of the B or D? So in this scenario, what will happen is D is +5. Let's say B is also +5 because you push the button. So the problem is B was already ground, right? So what will happen is when B becomes +5, there will be a current flow because B is +5 and the A is ground. So +5 to ground, there will be current running. Okay, you should understand that because both are Arduino's terminals, +5 and ground, you connected to Arduino. So one source. So whatever the +5 coming from Arduino's +5 current will go to the Arduino's ground. So that is fine. That is like a battery. So B become +5 because we push it. D is +5 already. So B become +5. So how do we compensate this? That because B was earlier ground. So A is ground. So that all the 5 voltage will be falling between the resistor. Understand? So since there is a resistor, one side of the resistor will be 5 voltage, other side of the resistor will remain as ground, and there will be a current running according to V is equal to IR. So you can replace V by 5 voltage, R by 1 kilo ohm or 10 kilo ohm, and you can even calculate the current value that is running from B to A. Okay, so now we don't have a short circuit. So this is what I said. This is why we need a resistor. You might have asked me what if you don't have the resistor at the beginning to give a ground initial state to pin number 2. If you do like that, if there is no resistor, there will be short circuit because from one side D from 5 voltage is coming and from A plus ground is coming. So if you push the button, 5 voltage and ground will meet and there will be a short circuit that may even damage the Arduino. Who knows? So by having a resistor, the resistor will bear that voltage. The resistor will handle that voltage. So B can stay as +5 while A is ground. Okay, and if you remove that button, Okay, that plus 5 connection is now terminated. There is no plus 5 connection, because if you take your hand, if you release the button, D will be plus 5 and B will again be ground, because there is no connection and there is no current is running now, because no 5 voltage is coming to B point. So B will remain as ground because there is no current running if you release the button like initial state. So let's just think, you press the button, E is plus 5, D is plus 5, and then B is plus 5, A is ground, and C is plus 5. So the input going to Arduino is now is plus 5, high voltage. Earlier it was ground. So now you take your push button off. What happens? Now there's no plus 5 coming to point B. So from point A, the ground will be going to ABC. 0 voltage will be go to ABC. So now what we have done is, if you press the push button, plus 5 voltage is going to pin number 2. If you release the push button, 0 is going to pin number 2. So push means high input is going to pin number 2. Release is low input is going to pin number 2. You understand? So this is what actually pull down means. Okay. So now we can understand, if we digital read the values, if the value is plus 5 or high, we understand the customer has pressed the switch. Or the user has pressed the switch. So whatever the logic you want to happen, if somebody is pressing the switch, you can implement it using an if condition. So we will study, when we study if condition, we will take this same example, and we will do that. That is another thing. So, and if the customer releases the push button, so let's say we digital read the pin number 2 value, digital read. So that is why I taught you the coding. If you don't understand, go to that part, one of the previous videos there, where the input coding is there, digital read coding. Have a look and come back. If we digital read the pin number 2, if that is ground value, that means the customer has released the switch. So whatever the logics that you want to happen when the switch is released, you can make it happen using an if else condition. I hope this is understandable. So you can see now switching is implemented. So this is what actually a kind of a type of switching. So there is another switching pull up. We will learn that later. Now this is it. So instead of push button, you can have a digital sensor as well. So that sensor, in this case, when you press the push button, only 5 voltage is coming. When we release it, we are automatically giving ground using that pull down circuit. So if you connect a digital sensor, okay, to this junction B instead of a switch, that can give plus 5 and ground by according to the environment, still there is no problem. If plus 5 is coming, plus 5 will directly go to the pin number 2 through B and C. A will be ground, the resistor will handle the voltage. If there is ground is given by that particular sensor, then still no worries, because already we are giving ground. Okay, so both will be same ground, because we will common cathode anyway. So just don't worry about that. We will talk about that later, because the sensor is also going to get power and ground from Arduino. So don't worry about that. Just think, if the ground is coming, we already give ground, so it will be ground. So no problem. What is the problem? There is no problem. So it will work perfect. So for the moment, you can just think about switching. That is enough. So the same thing is explained in this graph. So earlier the state of the pin is 0 or low or 0 voltage. So when the switch is pressed, it will go to 5 voltage. So that difference we can understand. Then you keep the switch pressed. So after some time you release the switch, so it will fall down to ground again. And another important thing is, you can digital read the values. So when you press the switch, the value will be 1, because it is 5 voltage high. Not digital read. Digital read and serial print the value. Serial printing, you know. So if you press the switch, the serial printing value will be 1. If you release the switch, the serial printing value will be 0. So have a clear look on this picture, or you can rewatch the video and get some idea. So just make you to understand, I will go to the coding now. So this is how the coding looks like. So this part we already looked in one of the previous videos. So if you don't understand, just go to the video, have a look on that and come back, because that video is anyway in the starting of the digital input sections or sessions. So it's easy. So inside the void setup, we starting in the line 4, we are starting serial beginning to print the serial values. So you don't need to worry about that. So we mentioned pin mode 2 as it is wrong. We have to mention it's an input, because switch is an input, right, to pin mode 2. So we are taking digital input. So this whole subject is about digital input. So input, and then we digital read the value of pin number 2. You see this? So these all things I explained in that video. You go and have a look and come back if you don't understand. So then I assign the values because I know either 1 or 0 can come, since this is a digital input. So I assign that value to an x called integer, an x value, variable of x, that is an integer variable. So I have defined it as a global variable on top. Okay, you can define it as inside the void loop as well as a local variable, that is up to you, but I have defined this, declared this as a global variable. So digital read value is whatever the value coming to pin number 2 will be digital read, and the whatever that state 1 or 0 will be assigned to x, and then I serial print the x value. So it can be either 1 or 0. So if you press the switch, you will see number 1 is printed because there is high. So high state x will be 1 and x will be printed, 1 will be printed. If you release the switch, then whatever the digital value of pin number 2 will be 0. So 0 will be assigned to x will be printed in this line number 10. So 0 will be printed. So you can immediately see the changes. So when we study if conditions, we will study, so when you press the switch, what we should do using an if condition, right? I will explain that later. When you release the switch, what the system should do, things like that. So for the moment, if you understand whatever I told up to now, that is great. If you don't understand, just rewatch the video and you will understand. So consider subscribing us. I will catch you in the next video. Have a great day ahead. Bye.